Okay, welcome to chapter 3.2, complex numbers. The essential question for the chapter is, what are the subsets of the set of complex numbers? So in your study of mathematics, you have probably worked with only real numbers to this point, which can be represented graphically on a real number line. In this lesson, the system of numbers is expanded to include imaginary numbers. The real numbers and imaginary numbers compose of the set of complex numbers. So what we have here is the set of complex numbers, which is a portion that is imaginary and a portion that is real. And real numbers can either be irrational or rational. And if they're on the rational side, they can be integers, whole numbers, or natural numbers. And so the complex numbers is, for example, a complex number, if I choose an integer, or a complex number, if I choose a real number and I come down to integer, well, an integer is a positive or negative number, no decimals or fractions. So 4 is an integer. It's also a whole number. It's also natural. And if I take plus 3i, for example, I now have a real number plus an imaginary number that creates a complex number. And that's what we're going to be doing in this chapter section. Okay, so we're going to start off with a core concept, the square root of a negative number property. So if r is a positive real number, then the square root of negative r equals I times the square root of r. So there's an example, and it says the square root of negative 3. And they don't really break it down, but if I took the square root of negative 3, that is going to equal the square root of negative 1 times 3. And then I can simplify that by giving each one its own square root symbol and breaking them up. So I have the square root of negative 1 times the square root of 3. And the square root of negative 1 is I, so it'd be I square root 3. And that's where it comes from. So by the first property, it follows that if I have a number, I square root r, and I square it, that will equal negative r. So I square root 3 squared equals I squared times 3, because if we take I square root 3 as a group and square it, then you distribute it, so it's going to be I squared times the square root of 3 squared, and I squared is going to become, I squared times 3, and I squared is negative 1 times 3. Think of I squared as the square root of negative 1 times the square root of negative 1. That's what I is. I is the square root of negative 1, and the square root of negative 1 times the square root of negative 1 is negative 1 times 3, and that will give us negative 3. Okay, so this is what we're going to be doing in this chapter section. So let's get into it. Okay, so example 1, finding square roots of negative numbers. So after you watch this example, pause the video, and you should be able to do problems 3, 8, and 10 from your homework. So we have the square root of negative 25 for A. So the first thing you want to do is break it down and take out that square root of negative 1 and make it the square root of negative 1 times the square root of 25. The square root of negative 1 is I, and the square root of 25 is 5. And we usually write it with the number first, followed by the letter I. So the square root of negative 25 is 5i. Okay, part B, again, take the square root, and I guess if you did put the number first and the square root of negative 1 after, then it will just line up. You won't have to flip it over. So the square root of 72 times the square root of negative 1. And remember, to simplify a radical, you have to do a factor tree. And that will be 2 times 36 is 72, which is 2 times 18, which is 2 times 9, which is 3 times 3. So I have a pair of 3's and a pair of 2's, and 3 times 2 is 6. And then I'm going to put this negative 1 here, and that is I. And I have this leftover radical 2 here, so that's going to be square root 2. It's going to stay there. So think about square root of 72 as being the square root of 72 is 2 times 2 times 2 times 3 times 3. And if I broke this up as a square root of 2 times 2, square root of 2, square root of 3 times 3, the square root of 2 times 2 is 4, and the square root of 4 is 2. The square root of 3 times 3 is 9, and the square root of 9 is 3. And then we have this radical 2 here, so we have 3 times 2 is 6, square root 2, and the I. And the proper way to write that is putting the 6i first, followed by the radical. So this is the answer to this number right here, problem right here, B. Okay, part C. So -5 is going to stay there, times the square root of 9 times the square root of -1. So all I did was split up this square root of -9 and made it 9 times -1. So that's going to be -5 times the square root of 9, which is 3, and the square root of -1 is I. So this is going to come out to be -15i. Okay, so after seeing those 3 examples, now go try numbers 3, 8, and 10. Okay, example 2, equality of 2 complex numbers. So after I do this example, pause the video and you should be able to do 14, 16, and 17 from your homework. And it says here to find the values of x and y that satisfy the equation 2x minus 7i equals 10 plus y times I. Well, we have 2 parts here. We have a real portion. This is a complex number, which consists of a real plus or minus an imaginary. So the reals I circled in red, the real portion, 2x is real, 10 is real, but 7i and y times I are both imaginary. So that's our complex component. Those are complex numbers with a real and imaginary component to them. So what you do is you take the 2 real components, 2x, and set them equal to each other. So 2x equals 10, the real part equal to the real part, and then I can divide both sides by 2 to solve for x. So x equals 5. So I found the value of x. Now it says find the value of y. So now I have a -7i. Don't forget that negative number. When I circled it, I probably should have included the negative symbol. So let me do that. So it's -7i equal to positive yi. So in this case, I'm going to divide both sides by I. So I'm trying to solve for y. So I get rid of these i's here. I divided by I is 1. Anything divided by itself is 1. So that's going to leave me with -7 on this side equal to y. So y equals -7 and x equals 5. Okay, core concept, sums and differences of complex numbers. So to add or subtract 2 complex numbers, you add or subtract their real parts and their imaginary parts separately. So the sum of complex numbers is a plus bi plus c plus di equals a plus c plus b plus d times I. And you're probably saying, what? Let me give you an example. 3 plus 2i. Okay, so that'd be this a plus bi. 3 plus 2i plus some c, which I'll call 4 plus 5i equals a plus c, which is the real part, 3 plus 4, plus b, 2, just the 2, plus 5, and then you put the I after. And then to simplify this, we'd get 7 plus 7i. So all you're doing is adding the real plus the real and the number in front of the imaginary I, both sides, and putting the I after. And that's basically it. Okay, I just realized I had made a mistake. I was looking at chapter 3, 1's assignment. So let me go back. So after example 1, I assigned you 5 through 11 odd. You should be able to do those after example 1. After example 2, you should be able to do 13 through 17 odd. And now we just did the core concept and we're on to example 3. And this is 21 through 27 odd should be able to be done after this example. So I'm going to do A now. So A says 8 minus I plus 5 plus 4I, and I'm just going to put equals, and I'm going to take the real component, 8 plus 5, and put that in parentheses. And I'm going to put this plus sign here, and I'm going to put a negative, there's a -1 here and a +4 here, so that's going to be -1 plus 4 with the I on the outside. So that's going to equal 13 plus 3I. Okay, part B, what we're going to do is we're going to take the 7 and careful, this is minus. So in parentheses, we're going to have 7 minus 3, the real pieces, 7 minus 3 plus, and it's going to be -6 minus 6I. So that is going to equal 7 minus 3, which is 4, and -6 minus 6, which is -12. So plus and -12 are simply -12I. Okay, and then finally the last one. 13 minus 2 plus 7I plus 5I. Well, they've just kind of rearranged this. So before I even do this, I'm going to just put this piece with this one. So I'm going to say 13 plus 5I minus 2 plus 7I. And I'm going to take the real pieces and say 13 minus 2 plus, and then 5 plus 7 with I after. So 13 minus 2 is 11 plus 12I. Okay, so there are 3 examples of how you add complex and subtract, add and subtract complex numbers. Okay, so here's example 4, solving a real life problem. Electrical circuit components such as resistors, inductors, and capacitors, flux capacitors, all oppose the flow of current. The opposition is called resistance. So for resistors and reactants, for inductors and capacitors. Each of these quantities is measured in ohms. The symbol used for ohms is this Greek letter right here. That's ohms. The uppercase Greek letter omega. So component and symbol. So the resistor is this squiggly line here. So the resistor is 5 ohms. The inductor is this curly thing here that looks like a spring, and that's right here, and that is 3 ohms. And the capacitor is where there's a break, and that's 4 ohms. And then the alternating current source, which is right here. All right, so the resistance or reactance in ohms are LC, impedance in ohms are L sub Li and -CI. So the table shows the relationship between the component's resistance or reactance and its contribution to impedance. A series circuit is also shown with the resistance or reactance of each component labeled. The impedance for a series circuit is the sum of the impedances for the individual components. So it says to find the impedance of the circuit. So let me highlight that. Find the impedance of the circuit. Okay, so basically what they're saying here is this squiggly line here is the resistor. So it has a resistance of 5 ohms. So it is 5 ohms here. And the impedance is equal to R, which is the resistance. So this is also 5 ohms. Okay. The L stands for the inductor, the inductance, which in this case is 3 ohms. So this is, let me change colors. So the inductor, the squiggly line here is right here. So that is 3 ohms. And therefore the impedance in ohms would be 3I. And then finally the capacitor, which is over here, that is 4 ohms. So this would be negative 4I. So it says find the impedance of the circuit. Okay, so all we need to do here is, love when I switch colors and it doesn't listen. There we go, red. So we want to look at this right here, because it says here the impedance for a series circuit is the sum of the impedances for the individual components. So the sum of all the individual components. So the answer to this problem is 5 plus 3I plus a negative 4I. So when I simplify that, the real part is only 5. There's nothing else that's real. What I want to add is 3 and negative 4, which would be minus 1, or just simply negative I. So the impedance for the circuit is 5 minus I ohms. Okay, and I didn't give any problems in the homework based off of this, but wanted to mention it in the video. Okay, so this is example 5, multiplying complex numbers. So after I do these 2 examples, you should be able to do 37 through 43 odd on the homework. And so here we go. Multiply, write the answer in standard form. So this is just simply the distributive property. So a positive times a negative is negative. 4 times 6 is 24. And then the I just comes after. So 4I times negative 6 is negative 24I. And then 4I times a positive times a positive is positive. 4I times I is 4I squared. Okay, so I'm going to stop right there, and I need to explain to you what happens when we take powers of I. So if I equals the square root of negative 1, then I squared is going to equal the square root of negative 1 times the square root of negative 1, which equals negative 1. Then we take the I to the third power, and that is going to equal the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And that is going to equal, since these two are negative 1, and this is I, it's going to come out to be negative I. And then I to the fourth power is going to be the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And the square root of negative 1 times the square root of negative 1 is negative 1. And same here. And when you multiply a negative 1 times a negative 1, you get 1. So this is, it's cyclic, it repeats. So I is the square root of negative 1, I squared is negative 1, then it goes to negative I, then it goes to 1, and it just keeps going around. This would be I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th, and so on, and so on, and so on. Okay, so I'm going to leave this up here just in case we need to use it. And we have an I squared right here, which is negative 1. Okay, so this is going to come out to be negative 24I plus 4 times negative 1, which is negative 4. And I want to put my real part first. So it's going to be negative 4 minus 24I. Okay, and then this one is the distributive property again, or FOIL. So 9 times a negative 4 is negative 36. A positive times a positive is positive. I'm doing outer now. 9 times 7 is 63I. And then the inner is a negative times a negative, which is positive. 2 times 4, which is 8I. And then finally, a negative times a positive is negative, and 2 times 7 is 14. And I times I is I squared. So these are like terms. So I'm going to get negative 36 plus 63 plus 8 is 71I. And I squared, remember, is negative 1. So that'd be 14 times negative 1. And it's negative 14 times negative 1, which is positive 14. Then I combine my reals of negative 36 and 14, and I'm going to get negative 22 plus 71i. Okay, so this is example 6, solving quadratic equations that may involve imaginary solutions. So once I do these two examples, you should be able to do 49 through 52 odd on your homework. And here we go. Solve a x squared plus 4 equals 0. So I'm first going to write the problem. X squared plus 4 equals 0. I want to get x by itself. We're trying to solve for x, so I subtract 4 from both sides and I get x squared equals negative 4. Take the square root of both sides. Okay, and that's going to give me x equals, and the square root of 4 is 2, and negative 1 is I. So in other words, the square root of negative 4, the square root of negative 4 is the square root of 4 times the square root of negative 1, and that is 2i. Okay, so the answer is x equals 2i. Okay, and the one thing I did forget though, when you're taking the square root of something, you always get a positive or a negative solution. So that should be plus or minus 2i. And now we're going to move on to this one. So we have 2x squared minus 11 equals negative 47. Getting the x by itself, I have to get rid of this 11 first. And that is going to give me 2x squared equals negative 30. 36, negative 36, and then I divide both sides by 2. So that's going to leave me x squared equals negative 18, and then I take the square root of both sides. So that's going to be equal to x equals plus or minus, and the square root of 18 I'll do off to here. Negative 18 is negative 1 times 18, and then 2 times 9, and 9 is 3 times 3, and there's a pair. So that's going to be 3 on the outside. Square root, actually the I comes first. So 3, the square root of negative 1 is I, and then the square root of 2 is still under the radical. So my answer is x equals plus or minus 3i root 2. Okay, example 7 says finding zeros of a quadratic function. So after I do this example, you should be able to do 55 through 59 odd on your homework. So it says find the zeros of f of x equals 4x squared plus 20. Well, what that means is if I want to find the x value that gives me 0 over here. So f of something will give me 0, or y equals 0. So the first thing I'm going to do is take my 4x squared plus 20 equals 0. Okay, and then I'm going to subtract 20 from both sides, minus 20, and that will give me 4x squared equals negative 20. Dividing both sides by 4 to get the x squared by itself will give me x squared equals negative 5. Take the square root of both sides and I get x equals plus or minus I square root 5. Okay, and that's all there is to it. Okay, that brings us to the end of chapter 3.2. And again, these are the exercises. Hopefully you did those as you were going through the video. All right, have a great day.